Welcome friends, I am Tanmoy and I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we are not going to learn any type of basic chemistry related thing. Today I will say something about myself or mainly about my PhD. So it's a 7 years journey. Generally it don't take that much time, but for me it needed, so we'll discuss something about that. First of all, I joined in IISER Kolkata, that is Indian Institute of Science, Education and Research, Kolkata. Actually, that time there was 5 IISER, so I joined in Kolkata. It is in Mohanpur. So at 2012, I have joined here after finishing my MSc in IIT Kolkata. So this is the institution background and what I have done. Mainly, I have done work on CO2 fixation. So, okay, and before going to that, I want to mention that right now I am eligible to write this word doctor in front of my name because I have finished my PhD. So I am now eligible to consider, or you can call me Dr. Tanmoy Biswas also. So this is the thing. So let's now discuss about the science, what I have done. So actually the basic thesis headlines, means thesis topic is metal free. Metal free, heterogeneous, means not headline, just topic. Metal free, heterogeneous, polymeric, material catalyzed, epoxide to cyclic carbonate conversion, under ambient pressure. Ambient CO2 pressure, carbon dioxide pressure. Okay, so this is, you can consider the main basic thing what I have done during my PhD time. Okay, so from the name onwards you can see the catalyst. It's a, actually I have done a catalysis, in a catalysis, and the reaction which I have done, that is epoxide, mainly you can say terminal epoxide, plus carbon dioxide in presence of some catalyst plus co-catalyst. Co-catalyst, and CO2 pressure is 1.02 atm roughly, using a balloon, actually CO2 filled balloon. We have, and what is prepared, that is cyclic carbonate. So this is epoxide, 3-member ring cyclic ether, and this is called cyclic carbonate. So from this study thing, you can just understand that in which feed direction I have worked mainly. Actually, I have worked mainly on CO2 fixation. CO2 fixation. So these area I have carried out my doctoral research. Okay. So question, why CO2 fixation is important? You all know that this global warming, climate change, all the things are very crucial, and it is essential threat for our climate security. This word is very important. Right now for you are a student, so it means in your textbook you may not find this thing, but very soon it will be widespread. Climate security. Okay, like we use the term national security, water security. So that another term will come, that is climate security. And UN, United Nations, right now focusing on this thing, climate security. You have to secure our climate because temperature, global average temperature increasing. So what is the bad effect? That is glacier melting. This is one of the thing. Cyclones, because if temperature of the sea surface increases, that will result in water vapor enrichment on the above atmosphere. So that will result stronger cyclones. Okay, that's the distraction. And glacier melting, glaciers are the source of fresh water. Majority of water is not suitable for drinking, mainly seawater. We have plenty of water, but among that, very few amount of water is drinkable, and that is mainly stored in some as a glacier which produces rivers, even some lakes like that. But and another thing we will say that okay, we also drink underground water, but that is not a permanent source. Okay, so that's a problem. So at least deeply. So if glacier melted, then water security. And for India, we have around 130 crores of population around. So think, if water crisis happen, then what will be happen? And Chennai is one of the very small, very minuscule example. Okay, so that is the thing. So we need to fix CO2, and in this context, trees are the best. Trees are the best. Why I am telling? Because they absorb CO2 from atmosphere, and produces carbohydrate. That is the most efficient CO2 fixation. Trees. Why I am saying? Because in atmosphere, carbon dioxide is around 400 ppm. Previously, I guess you have read about 300, but right now it is increased. Or we can write 0.04%. Just think how much. And majority of is nitrogen, around 77%, oxygen around 22-3 like that. Rest of thing is inert gases. So it is very less, and trees are capable to fix carbon dioxide from this very less CO2 concentration. Okay, so this is the uniqueness of trees. So my research, you may consider to focus this problem, but if you think who is the best, trees are the best, and directly if we say nature is the best to fix CO2, and due to our illogical human activity like excessive fossil fuel burning results in CO2, because we know diesel, petrol, coal, this thing we burn in order to generate energy, and that is the reason. Second is deforestation. You know, in news many people are destroying forests and for the agriculture and livelihood. That is another threat. So that is the reason for artificial CO2 fixation. And in this direction, I have chosen one reaction. This epoxide to cyclic carbonate. And what is my contribution in this? That development of catalyst. Co-catalyst is fixed. I have used quaternary ammonium halides like tetrabutyl ammonium bromide or iodide as a co-catalyst for this process. So this is N plus, Br minus or I minus I have used. So this thing you have used, they are also another use of phase transfer catalyst. Okay. So what we have developed? I have developed different catalysts who are capable to absorb CO2 efficiently. And what do I mean heterogeneous catalyst? Means no, heterogeneous means not soluble in reaction mixture. Okay, that is the main definition of heterogeneous catalyst. That is not soluble. So this catalyst plays in that. But if you ask what is my reaction mixture, completely know it's semi, because this co-catalyst is soluble. You know phase transfer catalysts are soluble in both organic as well as inorganic. Means organic and inorganic, both solvent as soluble. Fine. So this is. So in this case, what we have prepared? We have prepared in this case like different catalysts. Means mainly my focus is nitrogen rich, because you know that nitrogen rich like amine, imine, guanidine, actually it remains in cationic form, X minus. Such type of materials are efficient in CO2 fixation. So that is the thing. What we have prepared, many porous organic polymer, These are, I am not explaining that much, because I guess first let me give you the thing. In future, if you want this details, please write in the comment box. I will explain. Porous organic polymer, or another very important GC3N4. It's a very famous polymer. Graphitic carbon nitride. Graphitic carbon nitride. So this thing, etc. Even another thing, that is, if we write, this is the ionic liquid, X minus. It's a little surprising, because generally you have seen salt like NaX. Such type of thing you have observed previously. But what is this? This is an organic cation and inorganic cation, and that is the uniqueness of them, that they can absorb efficiently CO2. So that is the thing. I have used such type of material for this process. Okay, fine. So just what we have done, second, balloon means CO2 pressure. For this work, I have used about CO2 pressure 1.02 atmosphere. How I measured using a millibar pressure gauge is approximate. I can't say it is exact because some relative error may happen, but it's a balloon, very low CO2 pressure. What do I mean from this? Low CO2 pressure. Okay, the message I want to give. So that is the main difficulty. This is CO2 fixation under low CO2 pressure. So this is the thing we have achieved during. So now let's see what is the use of product, because whenever we do any type of work, the first question comes, the research you are doing, you are spending a lots of money. What is the use of this material? So whenever you are doing something in research, it is essential that what is the purpose of that research. Okay. So, okay, first let's discuss about the preparation, then I will come to the use. From how this epoxide could be prepared, I will explain in a dedicated video later on. Generally, we can have alkene from petroleum cracking. Okay, so from petroleum cracking, we can have epoxide, and in presence of silver catalyst and oxygen. I am not just saying roughly exact condition, I am not mentioning. Similarly, it could be converted into epoxide. Okay. So in presence of then carbon dioxide, which is a greenhouse gas. What does it mean? It is a greenhouse gas. Why? Because whatever the radiation comes to Earth's surface, means if you consider this is the Earth, this is our Earth. So whatever radiation coming to Sun, first hit the surface of Earth, first something absorbed in the some dust particle in atmosphere. After that, it mainly hit the sun. After that, it tried to go back to the space. Now what happened? Greenhouse gas like CO2 stops this radiation to go space. They try to absorb, they try to capture, keep the temperature into the atmosphere. They don't allow the heat to go. So consequently what happened? The temperature of earth increasing, and that is the global warming. Okay, so greenhouse gas causes global warming. Fine. So this CO2 as a greenhouse gas. So we are reacting these and greenhouse gas producing a cyclic carbonate. Then definitely the question will come, what is the use of cyclic carbonate? Cyclic carbonate is a versatile molecule. Why I am saying it? First of all, see this bond, CO bond, this is highly polar. See, this is, we know carbonyl is delta plus, this is delta minus, and because of these two oxygen, if this is, let me draw it. For example, this is fine. If it goes here, so what will be the consequence? That resonance thing. This is O minus, this is plus, and see there are two oxygen. So they can further donate their lone pair, in this way stabilize the plus. So means the plus charge is delocalized and consequently very high dipole moment, and means highly polar. Okay. Second, see there means we know that alcohol, this and alcohol is called protic solvent. Why? Because they have a loose weak OH bond. In this case, no weak, so highly polar, no OH is there, aprotic solvent. See, third, and that is the reason. Another thing, they could be used in third, lithium ion battery. Lithium ion battery. You have seen nowadays, means everyone I guess have mobile, and the battery of mobile is made of lithium. Okay, lithium cation. So that is the thing, lithium ion battery. So in this way, it produces lithium. When it is useful due to this nature, it could be used as solvent in lithium ion battery. Fine. And it could be used for other precursors. What do I mean? For example, this could be used for polycarbonate preparation, or even polycarbonate could be prepared directly from these and these under high pressure. So polycarbonate preparation, this is. Another is they could be useful as preparation for polyurethane. What this polyurethane means, I'll explain later on. So this is. So there are many, one of them I have just explained. So now let's discuss about the polyurethane thing. You'll understand what is the advantage of this. This is a big. Polyurethane is a very important polymer, and that could be prepared from dicyclic carbonates, because they are actually terminal epoxide, one side is CO2. So if I have two such type of epoxide attached together with some linker, actually I have prepared such cyclic carbonate also, so then it will result in this cyclic carbonate. Okay, so if it react with, for example, this NH2 and this NH2, it what will do? It will attack here, it will open, it will. So what is the product? So you can write exactly, just one side I am drawing. This is the O minus, so after that proton H plus will be shipped, this is OH. Fine. After that, this is double bond O, this is NH, again N, again in this way this will go. So see, this is the polymer. It's a very important industrially applicable polymer. So such type of thing. And what is the traditional route for polymer? Traditional route is reaction of this amine with isocyanate. NCO. Think what happened? This amine attacks here, it opens up and ultimately results in SIP. So what is the advantage of this method? Because this is moisture sensitive. You know that isocyanate can react moisture very easily to form amide. So this is moisture sensitive, but cyclic carbonate is not that much moisture sensitive. Actually, it's a carbonate ester. You can consider like that. Okay. So this carbonate ester very difficult to, because of this conjugation of these two lone pair. This is not that much electron deficient. That's why attack of nucleophile at this position is very difficult, because ester hydrolysis. So that is the thing, that is a stable, relatively better way. So this much thing I have done in my PhD thesis. So, and another thing, the one important point is heterogeneous. And what is the advantage of this heterogeneous? Heterogeneous means not soluble in the reaction mixture. Consequently, what it could be done? It could be recycled for multiple times. Recycle for multiple times. What do I mean? You have taken a catalyst used for one reaction. After that, you recovered. How? You can consider that is filtration. Because catalyst is not soluble in reaction mixture, so simple filtration can separate it. Or better, filtration is a technique, actually basic technique is filtration. It could be achieved better by centrifugation. You have read about centripetal force, centrifugal force. So based on that centrifugal thing, the centrifugation process is done. So the machine precipitates the insoluble part. So in this way the catalyst. So this is a better technique, centrifugation. So separate the catalyst and reuse for multiple times. I have done that. So this is that. And one thing you keep in mind, actually my research mainly focused on few points around green chemistry. Green chemistry. Why green chemistry? Because you can see producing a material using heterogeneous process, utilizing a gas which is hazardous for nature, fine, and performing reaction to, and another thing, see, it is atom economical process. Why? Atom economic, I know it may be difficult for you some time, but see, this research is little advanced, so just listen. So atom economic, what means? One molecule of this producing one molecule of this, target, but no waste is produced. So that is another thing in point of green chemistry point of view. So this is atom economical. Why? Because both are combined and this no byproduct is produced. And keep it in mind, nowadays there is a very good slogan for green chemistry. Means you can say very good way. The message is reduce. Second is reuse. And third is recycle. What do I mean? Let's consider paper. Piece of paper. First of all, reduce the use of paper because it's made from wood, from or trees. Okay. Reuse. If you have written a paper, chop the paper into pieces and utilize that paper pieces to prepare new paper. Reuse. Sorry, I made mistake. That is recycle. So reuse means, for example, this is the A4 sheet paper. You have written one side. Okay. The back side is vacant. So don't throw the paper, use the back side. So in this way, reuse and recycling. Even like lithium and batteries, people have reuse and recycling. That's why you see when there will be many phones, means old phones, you exchange with in Amazon or Flipkart, you exchange and they'll pay some money for that. Why? They recycle the ingredients. For example, lithium is not that much highly abundant. So if we recycle the lithium present in those batteries, that's a huge amount, because nowadays people are using huge amount of mobile phones. Second, the battery, inverter, lead sulfuric acid batteries. Those old battery, if you give them, they'll give some money. What they do? They extract the lead again and again use, because lead is harmful for nature. If you throw it in nature, it will contaminate, pollute everything, and ultimately due to bioaccumulation, keep this word in term, bioaccumulation, it enriches in our body. And another thing, in ecosystem we are the top, so it multiple fold increases bioaccumulation. So ultimately hazard is like that. For example, if fish is consuming contaminated food, we consuming that, so the fish body's thing we will consume. And how many fish we consume, for example, per month, just think, and corresponding that much amount is we are consuming. So that is the thing, green chemistry. So this is important, my research is important from green chemistry point of view. Means in the field of, if you say what is the division of my research, that is first of all green chemistry, second of all, if I say my research belongs to polymer chemistry. Why? Because I have prepared polymeric material. In every case, no monomer. For example, that graphite carbon nitride GC3 and 4, porous organic polymer, which is considered as POP, polyionic liquid, this thing, these are important. These are all are polymeric catalysts. Okay, so this is the thing. This is the actually total analysis of my research. Means not say analysis, just overview. It's a big 7 years, lots of things I've learned. So I think I should stop it. If you have any query, you can write in the comment box. Second of all, that if you want to know more about this CO2 thing, write me. In future I shall make more videos, because I have read many things about CO2 and its global status. And finally, nature needs us. For example, our nature feeds us from the time we born. So it is our time to take care of our mother nature. Not only nature, always consider nature as our mother nature. So our duty is to save our mother nature. So it is not essential that for that thing you need to be a scientist or do science. No. You have to take care nature. Initially what time you can take care surroundings. How you can do? Plant trees. Plant trees. I am trying to do something industrial process, fine. But if you do this is the best. As I told, this is the most efficient biomachinery for CO2 fixation. Plant trees, save water bodies. Save water bodies. I believe just do this too efficiently. You can contribute a lot for your mother, this nature. Because if we pollute our nature, we can't survive. So please be sympathetic, careful, and try to save nature as much as you can. If you want to know further, write me in the comment box, I'll make. So thank you everyone for listening. If you like my teaching, please subscribe my channel Chemistry of Molecule, and please press the bell icon to get the notification of every single video I upload. And finally, all the best wishes for you. Try to do something for nature such that our future and our future generation is secured. If earth is not secured, we will not be secured. So don't be disappointed or don't feel sad. Lots of work need to do, so we need to be energetic. We have to do it because they are our solution. I believe it's difficult, but we have to achieve it. And if we try to do continuously, means small effort on a regular basis will result a big conclusion or outcome after a certain period of time. So all the best. See you in my next video.